Okay, the root test is really just a repeat of the ratio test. All the concepts are the same in terms of the fact that we have this non-increasing nature. We have a situation where we have this speaks to the non-increasing nature. That's what we get. That's how we get convergence. This speaks to the fact that this violates the non-increasing nature. That's why we get divergence. And then the fact that this is inconclusive. In other words, we need to pick a different test. So it all kind of goes right along with the ratio test. It's all the same concept. The root test then has this characteristic of really, if we have this whole thing raised to a power n, so that's different than the last look, because we only had one part of that series raised to the power n. This is where we have the whole thing raised to a power n. And so we can just really quickly take the root of that entire expression, and that root is going to behave the same way that the series behaves. So in this situation, we're going to evaluate the limit as n goes to infinity of the nth root of 2n over n plus 1 to the nth power. And so the roots, the whole idea here is to get the roots and the power to cancel out. So we're looking at limit as n goes to infinity of 2 to the n over n plus 1. That's going to behave, the stuff under the stuff that's in the power is basically going to behave the same as the entire series. So I'll do a quick L'Hopital's here to evaluate this limit. As n goes to infinity, we've got infinity over infinity, so indeterminate, hence L'Hopital's. Derivative of the top is 2, derivative of the bottom is 1. So the limit as n goes to infinity is 2. Where does that fall here? That falls in the greater than 1 category. So we know that this series diverges because of the root test. Let's take this series, e to the negative n, as n goes to 0 from 0 to infinity, and rewrite that with a positive exponent. So we have a negative exponent here, and of course that just means it's, it should be in the denominator, because if it's negative in the numerator, it means we need to move it to the other location in a fraction. So we have 1 over e to the n, and so we're just going to do the root test on this. So we're going to go ahead and take the limit as n goes to infinity of the nth root of 1 over e to the n. And that's also 1 to the n as well. So that's really the limit as n goes to infinity of 1 over e. And of course, 1 over e is, approximately 1 divided by 2.7, which we know is less than 1. So since that's less than 1, this converges by the root test. And just an aside here, some people might look at this and some people might see that you can rewrite 1 over e to the n as 1 over e all to the n, because this is really 1 to the n. And so if we stick a 1 out front here, then we are looking at a geometric series, really. A times, we have an a constant. We have a common ratio, 1 over e to the n. And this r is 1 over e, which is less than 1. And so, if we apply the geometric series test, we also get convergence. So just kind of a quick note that you can use the root test here, you can use the geometric series test here. Both are perfectly fine to do. It's just a matter of what you see. Both are acceptable solutions. So just a little bit of a review here, just kind of guidelines for figuring out what tests to use here, because we're kind of getting to the end of all the tests. The first thing to do is look at the nth term and see if it approaches 0. If it doesn't, then we have the nth term test. So that's a quick test that you should look to use first. And then look for those special series where tests are really quick. So we've got geometric, p-series, telescoping. Remember, that was writing it out and getting things to cancel, and actually physically finding the sum, or alternating series. So those are tests that are real quick to do. And then you can do the more time-consuming things like the integral test, or the root test, or the ratio test. A little more time-consuming, but you can definitely look for patterns there. Something that you can integrate that doesn't fall into a p-series pattern. Something that has a root, or some factorials that need to be canceled. So and then the last thing you can do is look for a comparison. So this is the direct comparison and the limit comparison. Those are really especially this one, those are really time consuming, a lot of math involved. So that's kind of the progression you want to look for. So if we look at these, this one is, it would be much nicer if this one just looked like 1 over n as n goes from 1 to infinity. So we're going to have to do a direct comparison test here. We know that this diverges. And if we look at this, and this is 1 over n, then 5 over n looks like this. So if 1 over n diverges by the p-series test, then 5 over n being bigger will also diverge. And we can just quickly prove that 5 over n is bigger than 1 over n by multiplying 5 times n is bigger than n, which is a true statement. So we can see that this is a bigger series, so that must also diverge. Taking a look at this one here, we've got lots of options. We could do a limit comparison test with 1 over n. We could do a direct comparison test because 1 over n is still smaller than this. We could also integrate. That's a u sub, so we could also set this up as x over 2x squared plus 1 dx, where u equals 2x squared plus 1 and du equals 4x dx. So we could, oops, forgot the x there. So we could look at this as a 1 over u times 1/4 du. So we could, if we really wanted to take a lot of time to figure out whether it converges or diverges, we could look at it that way. Just as an aside, this one does diverge if you want to go through that exercise. And then this last one, again, 2 options. We see a power here, so we can think, well, we just learned the root test, so we can use the root test if we want to. But also, kind of in accordance to this last example here, where we could rewrite it as a geometric series. We can see that this is written in geometric series form, where we have an a equal to 1, right? That's the constant out in front here, and a common ratio of pi over 4, which is less than 1. So this is also converges if you want to go through that test. And we could also find a sum. So you kind of be leery of any question that asks you to find a sum, because the only way you can find a sum is for the only way we can find a sum is to use the geometric series summation formula, a over 1 minus r, or to physically calculate the sum by doing a telescoping and looking for that canceling to occur. So so anything is asking you to buy a sum, to find a sum, just kind of realize that these two things kind of should come to the top of your list.